Okay, so let me say a word or two about the first homework. Now, this is a proofs course, and I'm asking you, like, criticize some proofs or whatever. There should be a learning curve in this class as you get used to writing things more carefully. So again, I'm going to be tough with you on the feedback, but don't get discouraged early on. This is kind of a warm up to kind of think about things. Okay, in the first problem, you find yourself on a desert island and you're hungry. And you know that on this island, there are two types of human natives. There are the truth tellers. No matter what question you ask them, they will tell you the truth. And there are the liars. No matter what question you ask the liars, they will lie to you. You come to a fork in the road, and you know that one fork leads to food and the other one leads to certain death. Of course, you want to go to the food. At that fork in the road is a native of the island. But you don't know whether this person's a truth teller or a liar. You can ask one and only one question to determine the correct road to go down. So formulate a question that you can ask this native that you don't know whether they're a truth teller or a liar, that requires only the answer of yes or no that will get you to the food. So see if you can think about that. Number two, please criticize this one or go change your major and just go fishing or something like that. In this problem, I proved that you don't ever need to do anything. Theorem, the money you have is equal to the money you need. So I'll take you through this. If M is the money you have, and N is the money you need, well, the average is equal to, right? Let's average these out. So putting the two over to the other side. Now, if you multiply both sides by M minus N, which makes me feel like I'm kind of back in high school, it's one of those little exercises there. This is N squared minus N squared. Everybody agree with that? So rearranging this. Bring the N squared over here and the 2AN over here. Now, complete the square. Take the square root of both sides, and then add A. And so don't ever ask anybody for money anymore, especially that's what you need. Please, please, there must be some flaw in this, right? You see this kind of thing everywhere. You see it in everything from well-meaning but mistaken science to politics, right? Where they try to pull one over on you. Tell me what's wrong with this, because clearly this money you have is not equal to the money you need. If you don't believe that, just go out to the parking lot and look at my car. Number three is a problem that might anger up the blood and leads into some stuff we're going to do later. I'm going to play a game. So suppose that I have an infinite number of ping pong balls, right? A ping pong ball with a 1 on it, a 2 and a 3 forever and ever, right? I'm going to play the following game. I've got this very, very large bag that will hold as much as I need it to. At a minute to midnight, I put balls number 1 through 10, I dump them in the bag, and then I remove ball 1. At a half a minute to midnight, I put in balls 11 through 20, and I remove ball 2. At a third of the minute, midnight, I put in 21 through 30 and remove ball 3. You all see the pattern of what I'm doing here. Then a quarter minute, 31 to 40, and remove ball 4, and so forth and so on. Now, assuming that I'm superhuman and can continue this, of course, it's going to be problematic as I get closer and closer to midnight, but assume that I'm superhuman and can actually continue this process. at the stroke of midnight, how many balls are in that bag? And part B, let me change the game. What happens if I change the game and at 1 minute to midnight, I put in balls number 1 through 10, and instead of removing ball 1, I remove ball 10. And at a half a minute, I put in 11 through 20, and instead of removing ball 2, I remove ball 20. And at a third minute, I put in 21 through 30 and remove ball 30. Now I'm counting to 11. So think about this, and it might make you angry, but we're going to deal with that later. Finally, this is kind of a sad little story, but it's true. When I first lived in North Dakota many years ago, in the 1990s, there was a rather horrible incident that happened involving a DUI stop. So according to what happened is police pulled over this person who I think really was being naughty for a DUI, and the situation escalated, and the police proceeded to assault this person, beat him up, and then they urinated on him. Of course, this made a lot of people angry, especially the recipient, I'm quite sure. And of course, there were many protests about this. So I was watching TV one night, and one of the protesters was carrying a sign, one of those big old square signs. And this is what the protester had written on it. Protester, the police was video. Explain why this is probably not what the protester really meant to say with his or her son. Okay, so do your best with these. Think about them. Get any questions, give me a holler. Are there any questions at the moment? All right. Well, we can get to it then. I think we can. Okay. Oh, that's another thing. Some people ask me about books. I have, if you've looked in the required stuff, there is no required text for this book or for this class. There is a suggested text, and I believe that, you know, lots of people like to have books. That's a good backup. Do not spend $1 zillion on this, right? It doesn't really matter. You can get this book or one like it. You can get an older edition, get it for cheap. In theory, everything that you need is in my course notes, which are already published up on Canvas and on my web page. But a book is, I think, sometimes a good supplemental resource as well. Let's get right to it. So let's kind of look at the basics here. We're going to talk about language, logic, symbols, and notation. Actually, I do have up on the Canvas page a link to a table of some symbols that I use quite a bit. So let's begin this. So start definition. A proposition is a sentence that is either true or false. So, for example, the statement, Jim is a man. That is a statement, and it is either true or it is false. Right, everybody? There are 30 days in February. That is a statement. It's either true or false. By the way, which one is that? That one's false, right? There's never 30 days in February. What if I, and of course, the same would be true if I said there are 27 days in, well, actually there are exactly 27 days in February would be false. There are 27 days in February would be, that would be true because there certainly are. What if I said there are 28 days in February? Why is that one tricky?
Is there sometimes exactly 27 days, sometimes 27.
No, 28 you mean. Right?
Yes, 28.
Right, because the statement, there are 28 days in February, depends on what year you're in, doesn't it, right? February, in that sense, sort of takes on a variable, right? So whether it's true or false depends on if I am living in the universe of 2025, that statement is true. If I'm living in the universe of 2024, and I said there's exactly 28 days in February, that statement would be false. Can anybody give it another example of a sentence that's not a proposition? Will you turn off that? I'm just kidding. That's not a proposition, right? Because that's a statement that's neither true nor false. I asked her to do something, right? Can anybody give an example of a sentence that is neither true nor false, but it's not an interjection or it's not a command? Polar bears are cool. What's that? Polar bears. So you could get arguments on that, right? Because that's kind of a subjective thing, right? Maybe you think polar bears are cool, like don't. How about this? This statement is false. Can that statement be true? If the statement, this statement is false, is true, then that means that it's not true. What if what if I say the statement is false and that is a false proposition? That means it's true. This one's called this is often called paradox, actually. Now a proposition, we start with simple propositions. It's just a sentence to be true or false. The sky is blue, water is wet, grizzly bears are friendly. Of course, that one is big too. You can make more sophisticated sentences out of simple propositions. And let me start by showing you some easy ways to put things together. Let P and Q be propositions. Water is wet. There's only 10 days in February. Just any two sentences that are either true or false. Now we can make something more sophisticated out of this. The conjunction of the which we will write as this. Think of this upside down V as being and. It in. What do you suppose it takes for the statement P and Q to be true? Right. So what conditions on P and Q separately does it take for P and Q? So for example, water is wet. There are only 10 days in February. Now let me make this big. Water is wet and there are only 10 days in February. Is that true? It's not, right? Because the second bit screws things up. When is P and Q true, do you think? Yeah. That is correct. You need both. In the conjunction, you need both of them true. When you are both. Okay. This disjunction, and Q. This time, you write this way. Water is wet, or there are exactly 10 days in February. When is this true, do you think? You only need one of them, or both, right? Let me make that clear. It's true precisely when one of P, Q, or both and finally, the negation of P this is a little tilde in front of P. Think of Wayne's World. P, not, only put the not in front of P. When is this true? This. Precisely. When P is false. So for example, if P is there are exactly 10 days in February, not P is not there are exactly 10 days in February. And that is a true statement, right? Because February, I don't know much, but I know it's either got 28 or 29 days, certainly not 10, not exactly 10. Everybody understand this? So I think of like those cartoons I saw as a kid, conjunction, junction, right? The and means both have to be true for the truth of the statement, or means either one or both. And the negation is basically flipping things around, right? If P is false, its negation is true. If P is true, its negation is false. Okay, any questions on that? Truth tape here in a moment. We'll take a part one that's kind of more chunky, but definitions. The propositional form is an expression or a sentence involving one or more involving one or more, but we need to be super careful. I don't want to involve any, but one or more, letters representing propositions. Connectives. We'll see some more connectives in a, but for now, I mean, connectives take this. So in other words, a proposition is just a sentence, it's true or false. A propositional form is you take a bunch of these sentences that are either true or false and you link them up using these tools here, your and, your or your negation, to put it together in a larger, more complex sentence. And I want it to be well formed. What do I mean by this? Well, I mean for it to make sense. So I'm just going to do that kind of intuitively now. For example, PQ, not P not. These are not well formed. Because what does PQ mean? What does it mean to slap two sentences together? I don't know how these are connected. Is it and, is it or, is there a negation here? Things like this. These are not well. Okay. So what happens if you want to example, or if you want to examine whether a long, complicated propositional form is, when is it true, when is it false, right? So you can think of these propositions as variables, they're either true or false. So one can use truth tables to analyze propositional forms. Let me ask you this out of curiosity. How many of you in your travels thus far have encountered propositional forms? Okay, a few of you. There's no sin if you haven't, that's fine. Or how many of you have encountered truth tables? Right. How many of you are computer science related? That's one of the places where you see a lot of truth tables is computer scientists like to do analysis this way. Let me show you how to work a truth table. I'm gonna start with an easy example, and then I'm gonna get one that's got more teeth to it. So here's example junior. Okay, so let's look at so suppose that I walk up to you on the street and give you a couple of propositions here, P and Q. Both of these are sentences that are either true or false. I want to analyze P and Q. Okay. So let me ask you this. If I look at the sentence P and Q, and I want to know under what conditions does this animal turn out to be true? When does it turn out to be false? How many possibilities are there? Right? There are four. Okay, I agree with that. How'd you get that?
Because if P is true, then Q can be true or false, that's two. If P is false, Q can be true or false, so that's two more. So
Okay, I like that analysis, right? Each one of these has two possibilities, they're either true or false. If this is true, this can be true or false, so there's two ways to do it. And if this is false, it's right? So there's four things that can happen when I glue these two propositions together, right? So let me make our truth table here. Okay, there's four possibilities. P could be true, and Q could be true or false, right? And P could be false, and Q could be true and false. Agree? Okay, so here's the big cheese here, right? What's the status of P and Q here? It's true, right? Because these are both true. What's the status from now on? Right. In every other case, there's at least one false, right? And for this animal to be true, you've got to have both of them true, right? So you're dead in the water after this. Everybody okay? Okay. Let's do one that we'll all regret. How about this? Uh, um, let's do P and Q. Not R or S. I don't know about you all, but I've always wanted to know what the veracity of this is. So what do we have here? We've actually got four propositions in the mix, right? We've got P, Q, R, and S, right? And let's see, this is P and Q, which actually you can get from this table here, but I'm gonna do this from scratch. And not R or S, right? Biggest pain in the butt about this one is organizing the table here. The first thing here, I'll ask you the first questions that I did over here. I needed 4 lines to cover all the cases. How many cases am I gonna have here?
16.
Everybody agree with that, 16, right? Because 2 times 2 times 2 times 2, right? They each got 2 possibilities. Okay. So let's go through. And we'll see if I can make one like these. Actually, the big column today is 16 in here. Okay. Now I want you, while I am drawing these lines, like I'm in music class here, I want you all to think about, okay, how do I display these in the table, right? Okay, I know I've got 16 cases, but what's the most organized way to get these all to play out here? Right, I got 16 things to cover here. Y'all see what my concern is. I've got to go through all 16 possibilities, and this seems like kind of a pain in my butt, right? Because I don't want to repeat myself. And anyway, what's the best way to do this?
Do you do for P, you do the first 8 true, second 8 false, then for Q, you do the first 4 true, then the next 4 false, the next 4 true, the next 4 false.
Fantastic. That's exactly what you want to do. This is the most organized way to do it, I think. So let's do this. True, 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 true. The first half, first A. Right? And then false, 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 false. Right? Now, the next step, sort of take this and break it down into true, false. So cut this in half. True, 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 false, 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 false. And now do the same thing, because now we've got falses. True, 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 false, 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 false. Are you okay with this? And now in steps of 2. True, true, false, false. True, true, false, false. True, true, false, false. True, true, false, false. And finally alternating. True, false, true, false, true, false. Does everybody see that that works? So now we've got, every one of these outcomes should be sort of a different outcome here. Okay with that? Okay. I'm a real big believer in baby steps. This is still quite a bit, right? So let's break this down. We need to know about this here, P and Q. So let's just do P and Q. Okay, so I only need the first 2 columns to figure out what this column is. Agree? How does this one? What's the first entry? True. True. And in fact, the first 4 are, right? True. In fact, it might be easier. Everywhere I see an F, I have to have an F, right? Everybody agree with that? Because if either one of these is false, the whole thing false. So let's see what happens here. F, 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 F. Oh, it should be false all the way down. Looks like I got 4 trues, 12 falses. Can somebody tell me why that makes sense? Sort of. Isn't it essentially the same proportion here? Right. So that's the good thing about math, is you get used to it. There's all kinds of little things that sort of check you out as you go along the way. Yeah, so I look at this and I'm saying, yeah, it makes sense to me. All right. Okay. Because this will make it easier. So now I'm looking at R or S. All right, let's just figure out R or S. What does it take for this to be true? You just need 1 T. Everybody agree with that? So we're looking at just the R and S columns, and you only need 1 T. Right? So it should be T, T, T. Oh, that's a false. Okay, so it's only false if you have a pair of falses. That's the deal. That's the way to look at this. Everybody agree with that? There's only, I guess, 4 pairs falses. Now, again, with the baby steps, I'm gonna do this. Okay, so how do I get this column from the previous one? Just reverse everything. Everybody agree with that? So not false, 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 true, false, 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 true, false, 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 true, false, 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 true. Okay, so now we've got the big crescendo here. P and Q. And it's and, isn't it? And not R or S. Okay, so which columns am I really should I focus on? I should focus on this column here and this column here. So what does it take to be true here? You have to be true in both these entries. Everybody agree with that? Well, let's see what we got here. Are we ever double true? Right there. Goodness gracious, what a mess. This propositional form is false 15/16 of the time. Agreed? In fact, what do you need for this to be true? You need P and Q to both be true and R and S to both be false. Everybody? So how do y'all feel about that? Does everybody understand what we did there? Feel like you can reproduce that with something else? Okay. Good. So let me warm up to the kind of the next longer definition here. So I'm going to give you this as kind of a warm up. We say two propositions P, Q are equivalent if they have the same truth value. Right? Because remember, propositions are either true or they're false. Right? So if I give you two propositions, then I say that they are equivalent if they have the same truth value. Let me point out that these propositions need not have anything to do with each other. Right? So for example, these are insects. 36 is an even integer. These two are equivalent propositions. They seem to have nothing to do with each other, but they're both true, right? So from that perspective, we say that these are equivalent propositions. Okay, so two propositions, P and Q, are equivalent if they're both true or if they're both false. And if one is true and one is false, then they're not equivalent. What do you think the definition of two propositional forms being equivalent are? Well, instead of having just same truth value. How about the same truth table? Right, because a propositional form can be a big nasty mess, like that one over there in yellow, long sentence, lots of propositions involved. But we say that this is equivalent. Something else if they have the same truth table. So let me formally write that down. Definition. We say that the propositional forms say both composed of the same propositions. Number of course are equivalent if they have the same truth tables. Can anybody give me an example of two propositional forms that are equivalent? Let me point out that, yeah, oh, go ahead.
Would not P and Q and R or S D, would that get equivalent to what's up there?
I think you might be right. I'll write it down so that we can be careful about it. Well, let me start off with the smart aleck answer. Right. I mean, it better be. In fact, we're going to talk about something called equivalence quite a bit in this class. Equivalence is sort of a generalization of being equal. This propositional form is the same as this, so they better have the same truth tables, right? Let me give you one that's got a little bit more machismo to it. I won't take a stab at this one. Right. Not P is P. They'll have the same. Let me give you one, and I think this was Daniel's example, perhaps. And actually, there's many ways that I can do this. You might want to check this. What's the one that we had? P and Q, and not R or S should be P and Q and, remember how to do this, not R and not S. Notice these are actually different, aren't they? Right? I mean, these sentences are slightly different. It starts the same, P and Q and something, but here we have not R or S. Here we have not R and not S. Check it out. Do the truth table of this, and you will get that behemoth that we just did. It should end up like this. These are actually different sentences that have the same. These are different propositional forms, I should say, that have the same truth table. Okay. By the way, we're going to discover soon how I came up with this. Okay. Any questions? Any questions? All right. You guys put that in your patch and smoke it. Let me know if there's any confusion or anything I can help you with. Other than that, I will see you on Friday.